Uh, Good evening. My name is Afua James, and I'm going to present this work that we did, the assignment that was given to us. Yeah, name for the artificial intelligence assignment too. So we did this one in the group, and we actually made our own slides, depending on the way that we can explain it better. Yeah, and I'm going to begin with this with number one. Yeah, well, number one was actually asking us to introduce local search algorithms. Yeah, and the local site algorithms we know actually three. That is hill climbing, simulated, and the genetic algorithms. So now, beginning with the hill climbing is a straightforward approach that iteratively improves solutions by selecting the best neighboring state. And this is the why does it matter in this case? It is a practical and fast approach often used when resources are limited, providing quick and effective solutions in various industries. Yeah, that is what actually according to what we wrote, but this is just a summary of what I got. And in the real world example, it is actually used in scheduling problems like timetabling for schools to reduce conflicts between teachers, classes, and rooms. That is where the hill climbing can be used. The challenges we can face when we are dealing with the local search algorithm of the hill climbing, it can get stuck at a local maximum, failing to find the global best solutions at times. Yeah, like at times, teachers for within that real world example, teachers can still collide in class and causing conflicts. Yeah, and then the next one is the simulated annealing. So with it, A sophisticated this is a sophisticated algorithm inspired by the process of heating metals to reduce defects. And why it works actually in this when we are using it in the algorithm, it avoids the common pitfall of local maxima by sometimes accepting worse solutions early on, which helps escape potential dead ends. Yeah. So in the real world, this is how it happens in urban traffic optimization. This algorithm helps reduce congestion by exploring different configurations before settling on an optimal traffic flow pattern. Advantages: unlike hill climbing, simulated annealing balances exploration and exploitation, which allows it to escape local optima more effectively. Yeah, now with the genetic algorithms, this one mimics the natural selection process to evolve better solution. And why it's powerful, genetic algorithm handles complex, multivariable problems by maintaining diversity in the population, which ensures that a broad range of solutions is explored. In the real world, optimizing school bus routes, minimizing traffic time, and adapting to real world conditions like road closures and traffic delays. Yeah. So now the advantage in this is the use of crossover and mutation ensures continuous improvement and adaptation. Yeah. Now we are going to improving the above algorithms. By what I mean above algorithms, like in part A, which is the hill climbing, simulated, and genetic. So with the hill climbing, we are going to prevent the bias with using responsive AI and explainable AI. In the responsible AI, we are going to prevent bias by ensuring the algorithm treats all constraints fairly. For example, it should not overly prioritize teacher convenience at the cost of student schedules. So now when we deal to the explainable AI, this one brings about transparency in decision making, and this can improve trust, especially when the algorithm gets stuck and makes less obvious choices. Now, within the simulated annealing, responsible AI does it provides accountability for why the algorithm may choose worse solutions at certain moments. This transparency is crucial in sensitive applications like emergency management and healthcare scheduling. That is to deal in the hospital cases or the health centers. Then with the explainable AI, which is the XAI, standing for explainable AI, can explain countable, intuitive moves like why what solution was accepted to escape local optimum, enhancing user confidence. Genetic algorithms. Now, the responsible AI in this case ensures fairness in the solution process by making sure that the fitness function doesn't favor one group uh, disproportionately. Disproportionately. This is critical in applications like job allocation, where biased solutions could harm workplace diversity or satisfaction. Now, when the explainable AI comes in, since genetic algorithms rely on randomness and complex processes, uh, explainable AI can make them more transparent. For example, this solution was chosen because it maximized both cost-effective and environmental sustainability. We are meaning the genetic algorithm. Uh, Adversarial search and minimax algorithm. Adversarial search. In competitive environments, adversarial search models are decisions where each agent is directly opposed to another, such as in two-player games or competitive bidding. Why does this one actually matter? In zero-sum scenarios, one party's gain is the loss of the other. So understanding your opponent's move is crucial to success. So when an opponent makes a wrong move, it means for you are likely to win because you will have known how this person moves. That is how adversarial side works. And in that minimax algorithm, actually this is how it works. The player chooses the move that maximizes their minimum gain while assuming the opponent is playing optimally. Yeah. In the real world example, in competitive online auctions, bidders can use minimax logic to outbid opponents without exceeding their budget. That means they are not going to begin with higher prices when they are bidding. In this case, maybe if the product is uh, was uh, was maybe meant to begin with 50,000, for them they will put like 55,000, and then the rest of the opponents come in until when they see their opponents stop, and then now they can maybe put to 100,000 and then they take the product. Um, so the expect minimax and alpha beta pruning. So expect minimax, why it's different. Unlike traditional minimax, expect minimax integrates chance into decision making process, making it ideal for games with random events, e.g., that is dice based games like Backgammon. uh, Real world importance, it is crucial in games of chance or probabilistic outcomes where considering randomness leads to better decision making. Alpha beta pruning. Efficiency booster by pruning branches that won't uh, affect the final decision. Alpha beta pruning drastically reduces computational time, or let me say computation time, making algorithms like Minimax more practical in complex games like chess. In chess, pruning unpromising moves helps focus only on the most crucial probabilities, saving time while maintaining accuracy. Adversarial machine learning. Why it is important? Adversarial machine learning models can be manipulated by adversarial attacks, which introduce malicious inputs to deceive the model into making incorrect decisions. Now that is when we head to the machine learning. Now in the real world, these attacks can be harmful in sensitive areas like autonomous driving, where models could be tricked into misclassifying stop signs or road hazards. This can easily cause accidents. Types of attacks, that is poisoning attacks. This one is, it actually just alters the training data, leading the model to make incorrect predictions. And then evasion attacks, that one manipulates input data to cause misclassifications. And then the model extraction, this one recreates the model by analyzing outputs. And then now, when we go to the connection to adversarial side, both adversarial and adversarial side and adversarial machine learning involve strategic decision making, but while adversarial side is used in game theory, adversarial machine learning focuses on protecting models from attacks. That is actually the difference here. Thank you. My name is Paul James, and this is the work so far.